A very good morning to one and all for this day 2 program on a 5-day online international workshop on role of artificial intelligence applications to emerging technologies organized by Department of Electrical and Electronics Engineering, Prasadri Potluri Siddhartha Institute of Technology, Kanuru, Vijayawada. Today, our topic is on building trustworthy AI, simul tools to explain and improve your AI models. So our today's resource person is Dr. Vamsi Nellutla, is a principal data scientist, UHG, founder, Dallas Data Science Academy, Texas, USA. I take this privilege to introduce our today's resource person, Dr. Vamsi Nellutla. It is my pleasure to introduce Dr. Vamsi Nellutla has completed his master's degree in operations research in Indian Institute of Technology, Bombay, and he has done his MBA in business analytics in the year 2007. And in 2010, he has completed his associate certificate as managing virtual teams, Harvard University. And in 2015, he has tackled challenges on big data in Massachusetts Institute of Technology. And he has done his doctorate in North Central University. He has worked as a senior consultant at Tata Consultancy Services from the year 1997 to 1999, and has worked as process and data engineering leader at Verizona in the period 1999 and 2018. And also, he has established the Dallas Data Science Academy, a founder and president, in March 2016 until present. Presently, he is a principal data scientist in United Health Group and also founder of Dallas Data Science Academy from January 2019 till present. So it's a great pleasure having you here, Dr. Vamsi Nellutla, sir. Sir, you can hand over the session.
Let's see. Are you all able to hear me, team? Looks like some audio issues there. Are you able to hear me? Okay, good. Thank you, Hitendra, for that. Okay. Yeah, thanks for that, Bhavna. Thank you so much. So let me share my session here quickly. Okay. Okay. Are you able to see my screen now, team?
Yes, sir.
Oh, okay, gotcha. All right. Okay. So yeah, so what we plan to do, team, here is like, how do we build the trustworthy AI tools, right? So most of you might be familiar with ChatGPT. Some of you might be actually using the Gemini to actually do the programming and everything. So what we plan to do in this session, team, how do we actually build these trustworthy AI tools, right? And more importantly, why is the trust in AI definitely going to be a big factor whenever you are building the tools? I always start with this question. Let me actually pull out a small question for you all. So check this one here, team. So I have two students, right? I have two students, and then they both apply for a tech scholarship here, right? Both have around 9.0 GPA, and one is from CBSA and one from a small town state board. So let me know, who do you think is going to get the scholarship? So let's say, for example, if this person is person A, the one from CBSC is person A, and then one from a small town state board is candidate B. Who do you think is going to get the scholarship? Just give your best shot. Let's say, you can put your answers in the chat. I can check it out. You can tell me. There's no right or wrong answer. as you can see, right? So just tell me, like, who do you think will be a better candidate to get the scholarship here when they have the same kind of GPA? Read the question and then see. You see one answer that's from CBSE. Okay, gotcha. Any more answers, team? Out of the two candidates, CBSE one. Okay, all right. Any other answers here? Anybody who prefers like candidate B? It's kind of like a thin ethical choice, right? So all we have here is like a 9.2 GPA. We understand that. And we also get to see that, one person had studied in CBSE, one person has actually attended a small town state board. So there is this kind of like a ethical dilemma here when you are the person who is actually deciding, like, who is going to get the scholarship, right? Let's do one more question here, right? So here is the other thing. So we have two people and we have a heart risk app, maybe like a Fitbit, maybe like an Apple Watch, or maybe like a Samsung Watch here, right? So now a heart risk app rates a 45-year-old farmer from Telangana, and then like the rating of that particular person versus a software engineer with higher BMI. So who is less risky, you think? Think of like in terms of like heart risk, who has higher chances of getting any kind of heart ailment? What do you think? Farmer again. Okay, farmer. So that's the other thing. That's the other thing, right? Based on the conditions, whatever we tend to see, whether you are dealing with somebody who is like an urban area person, a software engineer working there, versus like somebody who is like an over 45-year-old farmer, maybe he's in the rural area. So all these situations, right? So whether you are dealing with a college admissions or whether you are actually dealing with a scenario where you are actually building some kind of an AI app within like a small watch where you are trying to predict like who is going to be less risky. So that's the topic of our discussion tonight, team. What we plan to do. It's morning for you all. So what we plan to do here is like, how do we actually build a trustworthy AI, right? So very first thing we need to understand here is like there are ethical issues. So you can see that we are saying like somebody who has attended a CBSE, for example, right? Somebody who attended a CBSE, and then like we try to actually give like more preference, or like somebody who is like a farmer, we might think like whether it's a higher risk or a lower risk. So what we are looking for here is like the ethics itself, team. Whenever you are trying to build any kind of AI tool, it's important for you to see like whether we are actually being able to embed all these moral principles here, right? Second thing here is like the clear accountability. So you actually predicted that somebody who has attended the CBSE will be having higher chances of getting a tech scholarship. Now you might have used the AI tool, or maybe you built an AI tool to actually predict this. So can we actually make that AI system clear accountable whenever it's actually predicting something, right? This is where the third thing comes into the picture, team. Most of the times, like, some of you might be familiar with the neural network algorithms, right? So you might have done some machine learning here. You might have built a model with a deep learning algorithm here. Now, we always tend to think whenever, we are trying to use a neural network algorithm, it's more like a black box. We just provide the data, maybe the algorithm figured it out, and then we are coming back and saying, oh yeah, the algorithm predicted, but I don't know like how it has actually predicted. This is important for us, team. Transparency is extremely important. Like, gone are those days where you come back and say like, yeah, I just used an algorithm and it tried to predict something, right? So you are coming back and saying like, are these processes really transparent here? And accordingly, you are going to provide the governance in the sense like, whether the model, whatever we are trying to build has got some ethics embedded, whether it is responsible, whether we can actually clear cut, we can actually mention this with a specific scenario of whether the results are transparent or not. That's the governance we are talking about. And the whole thing here, team, where you are actually combining the ethics, responsibility, and other factors is where you are actually heading to. It's called AI explainability, right? So where you are trying to build a understandable decision process. So in other words, like you can actually use, let's say, for example, ChatGPT. You ask a question about like a ethical question about like, should I do A or should I do B, right? So it's one thing that you are going to get an answer saying do option A or pick option A. Now, what we are looking for here is like, can we actually understand the decision process behind the system? So whenever you are actually working on any kind of building a trustworthy AI model, always here, remember team, ethics is a big part of it. We can't say a machine made a decision for us. And I'm going to show you some scenarios as well, right? See, whenever you're actually looking at the people analytics, right? So you're actually looking at the human rights. Say a specific scenario. One of the cases you might have studied, especially in US, right? There might be some ethnicity related decisions, right? So if two people go to the bank and if they are trying to ask for a loan, so, based on their ethnicity, sometimes people tend to think if people come from that particular ethnicity, there is a chance that, they might be poor and they will not be actually be able to repay the loan, right? So that is not something will be acceptable because like we have to respect the fundamental human freedoms. It's not about the caste, creed, or religion there. It's not about the ethnicity there. We have to consider the cultural diversity. Need to understand that, whenever you are trying to build a model, it has to work fairly across all the backgrounds, right? And also the explainability, like I was explaining, whenever you are trying to use an AI system and then you are trying to actually answer a specific question, it's always important, team. It's always important for you to understand, like, what was the decision process behind the complete decision? You took a decision, but at the same time, like, can we actually understand, make the people understand, make the users understand, like, what was the decision process? Can we recreate that? This is where the robustness. We can't say like, when we have 100 applications, we rejected 80 applications because of the ethnicity, right? So is the model robust? And then are we trying to come back and say like, if I submit 100 more applications, are you going to get the same kind of 80% rejection rate or not? Is the robustness that we are talking about. So whenever you're building a trustworthy API, AI here, always remember again, like, these are the key principles that we have to keep into consideration here, team. Human rights are extremely important. Diversity is extremely important. We can't actually make the whole bias creeping into the AI systems, right? You have to go back and then say, like, people come from multiple backgrounds, diverse backgrounds. Whether your AI model is able to handle it or not is the main thing there. Apart from that, here, team, what happens when you don't consider these factors, right? Some real world mistakes. So one of the thing here is like resume screening bias, right? Like we were discussing about a candidate who came from urban areas versus a candidate who came from rural areas here, right? So what we are coming back and saying here is like, if we have an AI system which was not trained properly, what would they do? The AI systems tend to reject all the qualified candidates. And what was the reason why it actually rejected the qualified candidates? Exclusively based on the gender or ethnic names. Classic scenario, somebody might be applying, a male or a female, right? Man or a woman. So when they apply for any kind of, let's say, for example, a pilot position. So if we have an AI system that is not really trained, so there is a danger there, team. If our system is actually having some kind of bias with the gender, the minute it sees like, okay, yeah, we have a female applicant applying for some kind of like a pilot position, and if AI is not trained, or like it tries to consider like, this particular name is tagged with a particular ethnicity, and it has got its own bias saying that, they don't make like a good pilots, there is a danger there, right? Here is the other thing, team, medical misdiagnosis. That's even danger, right? We are actually looking at like, patients receiving some incorrect treatments. Maybe the diagnosis itself is wrong, right? When we built the AI system, we did not have all the training data. So what did we do? Our AI system is not trained on some diseases. So that's where like, we tend to say, even if somebody just complains about some kind of a headache, maybe it might actually misdiagnose that as something to do with the brain, right? So that's the incorrect treatments we are talking about. The third thing is like the education assessment errors, team. Pretty much you are coming back and saying like, okay, I did everything good, but for some reason I did not receive the grade, whatever I was anticipating. What is the problem again? Same thing, students were unfairly evaluated by the algorithms. If there is no human in the loop and we are actually relying on some kind of an AI system and you are actually pushing it to evaluate students' performance, which, lacks the transparency, and it will definitely result some errors over here. So I'm not considering all the different problems are there, but most of these scenarios here, team, whether you are talking about resume screening bias, or whether you are talking about medical misdiagnosis here, or whenever you're looking at the education assessment errors, they are possible. If we don't build an AI system to handle these scenarios, there is a danger that these are going to impact the real life scenarios here, right? One thing here is like, especially for the job seekers, there was latest research that was performed, wherein like, if somebody is applying for a job, most of the times they have these ATS systems, right? Automated tracking systems or automated screening systems. What they do here is like, they actually tend to favor certain demographic profiles. So if you are not from a urban area, if you are not from a rural area, there is a possibility that these resumes automatically will screen and come back and say like, you don't fit into that certain demographic profile. So the algorithms are all kind of like intended to see favor all these demographic profiles versus that. It can be based on the ethnicity, it can be based on some other factors, but the problem here is like, when we are actually using algorithms that discriminate, it will impact the real life scenarios here, right? And here is the other thing. You apply for a job, and then like, all you get to see here is like, we are no longer considering you for our position, right? Pretty much everybody had that scenario, right? You apply for a job, and for some reason, like, you don't get any straight answer. All you get to hear is like, you are rejected. Now you want to understand here. So what happened? Like, you wanted to understand, like, so I applied for you thinking that I have all the qualifications for the job, whatever you have posted. Now, question here is like, understand that you rejected my application. They have the right. Employers have the right to reject any kind of application. But what is important here is transparency, team. Transparency is extremely important, where you are trying to ask them saying like, why was that application rejected here, right? And this is where we need to understand, like, we have to provide clear-cut explanations. So again, if you are part of a team where you are helping a small startup company, where they have a tool wherein like, they are actually evaluating the resumes and you are trying to screen them, keep this in mind, right? You have to take into consideration with algorithms are being applied with some discrimination here, whether we are being transparent to the candidate, and at the same time we have to explain back to the candidates like, how the decisions were made here. And the other thing here is like, if you're talking about healthcare team, talk about the healthcare here. Whenever like, we actually try to put our symptoms, let's say, for example, instead of having a registered nurse, instead of having a nurse or a doctor actually looking into your medical data, you are actually relying on some kind of an AI system there. So what happens in that case? There is a danger here where like, you are incorrectly categorizing the patient's symptoms, and that actually goes to the doctor, where they might come back and say like, I'm going to give you a treatment, but unfortunately that treatment is not the correct one. It's a wrong treatment, and they receive some inappropriate medical interventions over there, right? This is where we are talking about this ethical lapses, team. Can a machine really be helpful for us in diagnosing, right? It totally depends on like, whether we train the data properly or not, whether we train that AI system with proper training data or not, right? It's extremely important for us whenever you're talking about healthcare team. A student getting a wrong GPA is different from a patient who got entirely a different treatment for their problem, right? This is much more dangerous. And whenever you are talking about healthcare, it's important for you to have some kind of governance there. So understand that you're actually using a AI system to diagnose certain diseases. But do we have somebody like a doctor or a registered nurse who is actually validating that AI response here? That's important, especially in the healthcare here team. The third scenario that I was trying to tell you here is like an effects on the students and the education outcomes. Most of the times what happens, like, whether we do it as a human or as a machine, right? So you might have encountered those scenarios too. Like, a particular teacher have an impression about you. A student has a particular impression about the teacher, right? Bias can creep in from the student side or from the teacher side here. So what we are coming back and saying here is like, we are actually looking and coming back and saying, we are grading. If you are relying on AI system to grade the student, we are coming back and saying like, if people write in a certain way, if people come from certain backgrounds, what we're coming back and saying here is like, if you have certain writing style or a background, then, you might get a better grade over there. Again, that's the biased grade we are talking about, right? Other thing here is like, if we have a training data, take for example, right? You have two different ethnicities here, team, and then like, we have 100 people, and then like 90 people belong to one ethnicity. They take a loan, but they will never pay, never repay. We have 10 people, they take the loan and then they pay. Now, this is where we are talking about like, when if we give that training data to the AI model there, the existing disparities, whatever unbalanced data set you are actually passing to the system, to the AI system, it gets amplified. So what happens now? Any of that person, any of the candidates with the profile of that 90 people, if they apply for a loan, the machine thinks like, the AI system thinks that, okay, yeah, I was trained with this 100 people, 90 people who belong to that particular ethnicity never repaid. So the 91st person, he belongs to the same ethnicity. I'm going to reject that. So what happens in that case here is it gets amplified. It gets amplified. Whatever problem we had in our BAS system, it gets amplified whenever you are trying to automate it with the AI mechanism over here. As always, team, whether you are dealing with an education scenario or a healthcare scenario, it's always an important thing that, a teacher review. So the teacher reviews that fairness part, and then, make sure that there is a human in the loop and they are actually able to validate the AI system here. Hope it all makes sense, team. Right? Any questions, team? Let me take a quick pause. Any questions at this point of time? Do let me know if I need to go slow, if I need to go fast, if I'm trying to make this point. Do let me know. It's all good. Just raise the thumbs up if you like it. So far, so good. Then we'll move on here. All good so far? Okay, thank you. Thank you. Yeah. So one question here is like, if we don't have the trustworthy AI system here, there is a danger. There is a danger. In some cases, we are actually impacting the student scores. We are actually impacting the candidate who is applying for a job. In other case, we are actually impacting a patient here. So how do you actually build the trustworthy AI systems here, team? Some tips for you. We can build 100% foolproof system, but what is important for you here is like, we are going to work on having a diverse teams. Whenever you are actually building an AI system, it's important for you to include these ethicists, right? You wanted to have somebody who can actually question the ethics of the AI system. Why is that like, you are showing some kind of bias for certain kind of people? Like, why is that like, you tend to think like, these people are intelligent based on the writing style? So have ethicists. It's always important thing for the legal experts. They're just getting started with AI. So if you come back and say, I just used AI, people might get carried over. But if we are taking wrong decisions, legal issues will follow. Somebody might be actually suing us, saying like, okay, I'm a qualified person, but for some reason you disqualified me, right? So it's important for us, team, apart from the data scientists who actually build these AI systems, it's important for us to have these ethicists. It's important for us to have these legal experts here, right? Whenever you are building it, whenever you're building a system here, team, always ensure like, it's transparent. What does that mean? You are going to document all the choices and more importantly, the limitations. A classic example, I'll tell you, right? So I was working with working with a startup here where they wanted to understand like, if anybody goes through a cancer treatment, right? If somebody has unfortunate cancer ailment, so they will go through these chemo sessions. So what we did was like, we built a system where we came back and said, the AI can predict if you are admitting 100 cancer patients, the AI system can actually tell them saying that, okay, how many people are going to be readmitted within 30 days, which is not a good sign, right? Somebody has gone through a cancer treatment for so many chemo cycles. And then like, we are seeing the candidate back in like 30 days. That means somewhere the treatment went wrong here. So we built a system wherein we consider all the patient features like, patient age, patient BMI, patient whether he's a diabetes or not, what are the heart ailments, number of chronic conditions, all that stuff. So you built it. So, the machine started predicting. So when I get a patient profile, the AI system will predict whether that particular person is going to be readmitted within 30 days or not. Now, predicting that one person is going to be readmitted within 30 days is one deal. But the second thing here is like, how did the machine predict, right? Is that based on the chronic conditions? Is that because like, we have a profile of similar people who got readmitted within 30 days after taking the chemo session? That's the transparent design we are talking about, which gets to the next point of like, clear communication team. We need to tell them, let's say, you are working for the hospital. You're working for the hospital management system. You built an AI system now. Now you're actually asking AI to predict whether this person is going to be readmitted or not. But you need to understand, like, what's the AI role here? Are we coming back and saying, like, my AI system says that you are a patient who will not be treated. You are going to come back within 30 days. I don't want to have like a bad name for my hospital. I'm not going to admit you, right? That's one extreme we are talking about. So the patient might actually sue. The patient might actually go back and then like, go to the court saying like, okay, I tried to get cancer treatment from so-and-so hospital. And because of the AI system, it came back and said and predicted that my cancer will not be cured. So, legal issues might follow here. This is where we need to tell them like, what is the AI rule? AI role here is more like a decision support system. It's not the final verdict. We're not telling like, the AI told us that, you are going to be readmitted within 30 days. All I'm saying here is like, and I'm going to use that as a decision support system because the AI said the chemotherapy might not be working for you. We might actually take extra care for you. Right? So that might be a better way of clearly communicating the role of AI over there. Right? As is the case with the healthcare here team, the governance must be there across all industries. You go and establish all the ethical oversight processes. When you have these ethicists, when you have these legal experts, when they work with you, maybe tomorrow you might be a good AI engineer or a data scientist, right? This is where you're coming back and saying you have to have some set of rules. Tell them saying like, okay, what is the ongoing governance associated with it? One more team, when you are trying to do the transparency and explainability here, always ensure that when you're using an AI system, you have to have the clear reasons. Hope we kind of like emphasized and re-emphasized here, right? Say if you have a user, you apply for a home loan, for example, or you apply for an auto loan, you wanted to get some loan from the bank, right? So when the loan gets rejected, it's important for us to understand like, why a loan was approved or denied here. Is that because of the credit score? Is it because of like, maybe they're not really satisfied with the documents, whatever it is. Second thing here is like, regular testing for bias team. That's important for you. Let's say take for example, right? You might have actually considered all the students who are like college educated. Say you are working with a bank and you come back and say like, okay, anybody who has done some professional courses, right? And then like, you build a system only with such people data. Now, what if I have a rural person applying for a loan at the same bank? Because we did not train it, because we did not consider that particular demographic in our training data, we don't know. Our AI system might come back and say like, okay, I reject the application here. So this is where it's important for us to have this regular testing team. You build a system, step number one. But at the same time, you need to do regular testing here. You want to understand like, did any time bias creep in? So you wanted to understand saying like, okay, yeah, I train my system with both college going people, non-college attending people. And again, like, that's how you fine-tuned our algorithm or the model here. That actually leads to trust here, team. Whenever you are coming back and saying, it's one thing saying like, we are using AI for this, right? People might be really impressed. Oh, you're using AI. Awesome. But the second thing here is like, when you are using AI, how do we know that, it's making the right decisions here? When you are trying to interpret the decisions, you are actually running this fairness auditing here. That will automatically create the user confidence. They will be definitely be impressed, saying like, okay, yeah, they are actually using an AI that is explainable, transparent, and we know why or how a particular decision has been made over here, right? So for this particular section, team, whenever you are actually using the trust as a foundation for the AI's future, trust me, what the research says here is like, the user adoption rate. You have an AI system which is not transparent, and you try to actually push it to the users. Not many users are really trusting that system over there, right? So this is where you're coming back and saying, whenever you are actually building a trusted AI system, more than 95% of the people are able to acknowledge that, okay, yeah, I have that AI system which I can totally rely on, right? Second thing here is like, whenever you are considering this ethical processes team, you make sure that there are no bias or variance creeping in here. So you will actually help you to reduce the errors by more than 80% there, right? Which suggests like when you're reducing the errors, your efficiency will go up, your effectiveness will definitely go up. That will actually help you to build better, more transparent AI systems over here, right? Again, quick pause here, team. Any questions on the content we discussed so far? Anybody got a comment? Do let me know if something confusing. Hope the examples are making sense for you all. So if you need more examples, do let me know. I'm watching the chat as well. Put your questions in the chat, team. If you have anything there, if you want any particular topic to be explained in a more like a practical way, do let me know. Right? See, one thing I want to make you all to understand, like how AI explains itself, right? So one is this black box challenge. Some of you might be familiar with this neural network algorithms, right? Neural network algorithms are awesome. Hats off to all those things. Maybe you're using a random forest algorithm or an XGBoost algorithm here. You're building it. Right? What is the problem there? The explainability. Complex models, exactly. Complex models, more specifically, team, they hide the entire reasoning process, right? So you come back and say, I'm going to give you like 100 different people. You go ahead and then tell me who is going to repay the loan. You come back and say like, okay, yeah, I have this neural network algorithm, which is actually allowing me to make a decision. That's not going to cut it, team. That's the black box challenge we are talking about. And laws are increasingly demanding, especially Europe and US. They come back and say, you cannot tell me saying like, AI made a decision. You need transparency there, especially all the GDPR rules. They're coming back and saying like, okay, if you can't explain how a particular decision was made, it doesn't matter what kind of AI technology you are trying to use. So it's important for you to tell me like, how did you make the decision over here, right? Which also leads to the stakeholder trust team, right? So majority of the corporations, most of the corporations are trying to embrace AI here. But the problem here is like, would stakeholders really trust, right? That's what you're looking at here. If we can't explain why a particular or how a particular decision has been made, so that actually leads to stakeholder trust here. Right? So we need to understand like, whoever is actually trying to help us with the governance and whoever is developing the system. You are the data analyst, you are the data scientist, you are the machine learning engineer. You all need to understand the AI decisions here, right? Yeah. Bhavana, you have a question. You take up any one algorithm, how to represent in terms of coding for any application which you are discussing. Yeah, we can actually open up a neural network algorithm, except that I don't have a data set here, Bhavana. I can actually showcase an algorithm here. I can showcase a package which will actually run multiple algorithms here. I will try to do that. Majority of the data sets, they have some confidential elements. That was a problem. So if you have, I'll try to see. I'll try to see, like, maybe I'll share this after the session to you. And then, like, you can share with the students. And then that should help you. Yeah, I'll definitely make a note to send you all a code element, like how we can actually implement these practices here. That's a good one. Yeah, yeah. Explainable AI here, team. Explainable AI will definitely help you to interpret the model outputs. I'm going to give you like 3 different techniques. Like Sharp is a wonderful tool. I'm going to show it to you in a bit. So there is something called XAI, which we call it as like an explainable AI. It provides the techniques to interpret the model outputs. So you have a model that you built, pick up any of your favorite algorithms there. But there are tools. There are tools that can actually tell you to say like, how do I actually interpret this model outputs? What are the benefits again? One thing is the transparency. You come back and say like, I have an algorithm here, and then I'm going to predict something. you know for sure, like, how that particular algorithm actually predicted that output. And that also help that also will help us, like, to find out like how we can actually debug the entire process. Somebody might be saying like, okay, yeah, can you actually help me to understand, make me understand, like, how did you predict that? So we can debug that code much more effectively here. And again, same thing, right? Organizations, you can't say that, I'm using an AI system and it took a decision for me. It also will tell you when you're actually implementing this explainable AI, you can actually demonstrate the accountability here, right? There are three different approaches here, team. Each of these are like packages in Python. Most of you might be familiar with Python there, right? We can actually use each of these packages to do this explainability model. Two things, my favorites, Sharp and Lime. So in other words, like what they do here is if you use either Sharp approach or Lime approach here, team, both are equally good. What they do here is like, say you build an algorithm. You built an algorithm to predict if somebody is going to repay the loan or not. Now, you can build a model, you can take random forest algorithm or XGBoost algorithm or extra trees algorithm, neural network algorithm. You can take any of these algorithms there. After that, you try to use this Sharp or Lime. It actually goes to the feature level. It actually goes to the feature level and comes back and says like, okay, these features are important. Maybe you built the model considering the age of the patient, but with the way you build the model, maybe it's not looking at your age. It is actually looking at the number of chronic conditions over there, right? Both are equally important. So the way it works here again, team, I will definitely try to provide the code to you all. How do you actually implement this Sharp with the Python code? What it does here is like you take the features. You have a data set with multiple features. You build a model. You actually plug in a Sharp feature there. You can actually use that as a Python package. What it does is like it tries to calculate the feature contributions. What exactly is a feature contribution here? It actually gives you a rating. It can be normalized between 1 and 10, or it can be like a percentage. Say you are looking at the age of the patient, whether he is diabetic or not, whether he has a blood pressure or not, and you are trying to predict if that particular person is a cancer prone or not. So now, if you actually use the Sharp model, it can actually come back and say, yeah, whether the person is a diabetic person, is that what is being considered as a major factor? Is the age of the person being considered as a major factor? It's going to calculate the feature contributions here, team. One of the best part here with the Sharp is it actually visualizes the importance here. So you will get a nice chart that tells us like, okay, what proportion of the particular factors is influential there, right? The third thing it actually does here is like, it actually examines the global patterns, team. It's not for one single prediction. It actually goes to the training and the test data, and it comes back and says which features matters most overall here. When we have that information, then this is where, you as a human data scientist, right? You as a human in the loop, as a data scientist, you go back and then say like, whether the verified protected attributes don't duly influence the decisions here. What does that mean? Let's say, for example, gender of a person, ethnicity of a person, religion of a person. You wanted to understand saying like, okay, yeah, Sharp is going to look at your model. It's going to come back and say whether it's a fair model or not. Are you giving undue importance to any of those factors which you are not supposed to do? So that's a very good package here, team. Sharp. Make a note of that one, Shapely Additive Explanations. The other factor here is the line, which is the local interpretable model agnostic explanation. As good as the Sharp, I do have a comparison chart, when to use the Sharp, when to use the line. Same thing. What it does here is like, in case of Sharp, it goes at the feature level. Here, what it does is like, it creates a slight variations of the original input. Let's say, for example, you have a patient data set, and then you have patient age going from like 18 years to like 60 years. What this tries to do here is like, okay, what happens if I have a patient who is like 16-year-old, or what happens if I have a patient who is like 62-year-old? It tries to make slight variations of the original input, and it tries to come back and say like, whether the particular feature is going to be influential or not here. Based on that, it extracts the explanations here, coming back and saying like, okay, you gave me 10 different features. You understood you have like 10 different features in the data set. You want to understand like, which features really matter most for the specific prediction over here, right? And you also get the model predictions for each of those small variations, whatever you have considered here. And again, like you can call it as a black box model, but still you are going to understand like which feature is important for you. And once we have that simple model done, we are going to fit that simple model that can be interpretable over here, and that mimics the complex one. So the approach here is like you build a model in simple terms, then you try to add more and more features by having the small variations here. You will end up building a complex one over here, right? It starts with the linear regression team. I think most of you are familiar with algorithms here. Otherwise, it's perfectly fine. So whenever you are trying to build a regression model, whenever you are trying to predict something, right? One of the basic machine learning models here is like a linear regression that might be using a OLS technique to figure out like, okay, what are all my predictions here, right? One more thing here is like apart from the sharp package and the lime package that we have in Python team, this is something more like a counterfactual explanations. Is a technique that we are going to use as a human in the loop. What does that mean? Like you come back and say we have a 65-year-old person applying for a home loan, and his home loan gets rejected here. Right? So we are going to start with a specific prediction to explain. So now question here is like, why is that a 65-year-old home application got rejected here, right? So is that because of the age, or is that because like we don't have any confidence in his earnings history? So you try to do a minimal changes that flip the outcome. So let's say, for example, we have a 65-year-old. Instead of 65-year-old, let's say a 60-year-old. Let's make the age as like 60-year-old and also tweak with the earnings here. So now, would that actually make any decision? Would that actually impact the decision about whether to give him the loan or not here? That's what we are actually looking at, team. Counterfactual here is like, we have the factual data here. We tweak the data in such a way that, we are going to understand like, if the person is not 65, what happens here? So if we get similar results, that's when we'll be able to do the fairness over here. We can actually evaluate the fairness to come back and say like, okay, yeah, this is not actually relying on that person's age. That's really good. This particular application was rejected not because of the income there, right? And that actually provides the actionable feedback, team. You go back and then say it's not the age, it's not the income. The model is pretty fair there. So, we can actually provide the feedback to them here, right? So if you want to compare here, Sharp is really good team. Whenever the strengths for that here is like, you can have these for the consistent results, pretty robust package. You can always get a global plus local view. And best use cases for you here is like, high stakes, healthcare. Perfect example for you here is like, if you are trying to use that for the healthcare, I would say Sharp is a perfect technique, perfect tool for you, right? Same thing in case of Line. You go for speed and simplicity. You go back and then say, okay, yeah, I want to actually have like a quick solution here. I want to validate my model quickly. I don't want to use many resources, computing resources there. Then you certainly use for the Line. The best use cases for you here is like, real-time analysis. Maybe you are getting the patient data as a batch processing data. You take that batch data over there and you are trying to build a model, and then you are actually running this line to understand like, whether your model is a fair model or not. Counterfactuals is not like as straightforward as Sharp or Line, but what you are trying to do here is its particular parts. It's very, very important for us to understand it's an actionable thing. That's its strength here. And where you are trying to use here is if you have some ethical dilemmas, if you are trying to understand like, the ethical analysis here, should we do it or should we not do it based on certain considerations there? You can definitely use this, right? Hope that's clear here, team. You have the first part was discussing more about like, why AI fairness is important. The second part is actually giving you some tools, especially if you are doing in Python, like, Sharp and Lime and counterfactuals. These are good techniques for you to make sure that your models are really robust there, right? Real world applications, again, team, based on the projects we do at Dallas Data Science Academy, we do get multiple AI startups there. So, one of the healthcare projects we recently finished was exclusively based on the clinical analytics. We worked with physicians there. And what we are trying to do here was whenever they are actually using our AI system as a decision support system, doctors use the Lime to understand the diagnosis, right? So you provide the symptoms, AI system will provide the diagnosis here, and we are being transparent to the patient, like, how we are actually using the AI. This actually helped us to gain the confidence here, right? Same thing in the financier team. You go to the bank, whether the loan decision, whatever might be the loan decision here, you are curious about, like, why the loan got approved, why the loan got rejected here, right? So you can use sharp technique. You can actually use the sharp technique that meets the regulatory requirements. And obviously, it definitely builds the customer trust. Hiring decisions, again, team, hiring decisions. Why was that the candidate application got rejected over here, right? They will definitely help you. When you use the counterfactuals, are there any discriminatory factors that we have in our system? Are we using some kind of discrimination to discriminate certain kind of students or certain kind of candidates? You can actually use these techniques over here, right? When you use this sharp, lime, or counterfactuals, trust me, as a data analyst, as a data scientist, as a developer here team, we can always track the model errors. No model is perfect. Most of them are useful. That's what they say, right? No model is perfect. Just like no human is perfect, no model is perfect, no AI model is perfect. But what we are trying to do here is, like, we understand the errors that will be made by the AI system. We can actually be transparent and then say, go back and then tell the client, like, the strengths and weaknesses of our model here, right? One of the other things, I think there were a couple of questions where they were asking, saying, like, how about the computations, right? How are these tools going to impact the performance team? Sharp, to be honest, they're extremely expensive. They're extremely expensive for the large models here. Either you have to have that balance over there, whether you want to have at the feature level, which feature is important. But sharp calculations can get really expensive, especially if you are dealing with high dimensional data set here, right? And Lime is one thing. Whenever you're trying to approximate, Lime tries to consider a slight variation of the existing data here, but that might be like oversimplification there, right? So there are challenges there with these packages as well. Again, not 100% foolproof, but it might actually cause inconsistency. That's where, I would suggest you to use both these techniques and then see how it happens here, right? The third thing here is the privacy concerns here, team. If you are actually telling somebody that how your AI model really works, right? For example, ChatGPT. If ChatGPT really comes back and says, I have used so and so data for training my model, not everyone will be happy. Might have seen, might have heard about this lawsuit saying, like, New York Times, Washington, Wall Street Journal. They're all trying to sue ChatGPT because, like, they thought, like, maybe, you were using our data to train your models, right? So you're training your AI models without actually checking with us. So that's a privacy concerns over there, right? So when you are providing detailed explanations about, like, how your AI model really works, that might not go well in all the scenarios over here, right? So what is important for you here is explainable AI is good, but that doesn't guarantee any kind of bias removal here, team. Human in the loop. That's what they say. Human in the loop. Finally, a human judgment remains absolutely essential for us so that, we can actually make the models more useful here, team, right? Uh, the future is all about this. More and more systems, more and more regulatory controls are asking it, saying, build an explainable AI. It's okay to use the AI, but it's important for us to tell us, like, why AI made that particular decision over here, right? How do we make our AI systems without any bias, team? If you're looking at, like, fair and responsible, here are some quick tips for you, right? So you want to understand, like, whenever you are building a system, always remember it's inheriting a human bias. Right? Each of us, team, each of us, there is a Harvard bias exam as well. You can Google it. Each of us, we have bias. Sometimes HR calls it as a discrimination, right? Each of us have our own judgment. You look at a person, you tend to have a certain opinion about that person. Now, some people will have good impression, some people might get bad impression. What actually makes it to happen? Well, it all depends on the training data. Maybe you looked at that person who looks similar to that, and then, like, you have an opinion about that person. So if you have a person coming from the same cluster, we tend to have our own bias. Now, the problem here is If we actually pass that human bias into these AI systems, they inherit that. They inherit that when you're actually providing the training data here. Right? So the main problem here is like, if your training data is biased, even the AI system that you're actually building it will have the bias over here, right? And this is another thing. More if the training data is not good, the quality is not good. 35% of the organizations report this AI fairness incidents team. We have like 10 people who always tend to reject loans for senior citizens, and those 10 people actually build a system with an unbalanced training data set, and that actually led to saying like, the organization came back and said, we can't actually take this because your model is not fair. Your AI model is not being fair, right? And same thing here, team. It's one thing that, out of 10 people, 2 people have human bias. But if we are not training the AI systems properly, the algorithms can magnify. Everything is being done on a scale. Maybe as a human, you might actually go through like 50 student applications. But if you pass like 5,000 applications and the model was not done properly, what happens now? It magnifies the social inequalities over there, right? And these biases again, team, we don't realize that. Sometimes we get carried away with the accuracy. Oh, I built a model with 80% accuracy, 90% accuracy. But the problem here is like, there is an inherent bias in our model. Our model actually is predicting wrong things for certain kind of profiles over there. And that might not be visible immediately, invisible to the developers here. That's the main problem there, right? So real world consequences again, practical applications there. So here is one example, team. There is an algorithm called Compass that showed almost like 45% false positives for African American defendants, right? So if I have an African American defendant, if I have a white defendant goes there, what it found out here was like there were like almost like 45% false positives here. They tend to predict saying like, okay, yeah, this person is guilty, right? It was 45% for black defendants versus 23% there. Same thing. When you're looking at Amazon's hiring practices there, they actually penalize the AI resumes anytime like, they see some kind of women's terms listed in the resume there, right? So that's the gender disparity we're talking about, right? Same thing with the healthcare inequity. So we are looking at these black patients by 35%. They came back and said like, these people are supposed to get the benefits, but because the algorithm was not actually built properly with the proper training data, what did it say? It came back and said 35% of the people who submitted from that particular ethnicity, they were all being rejected over here. So anytime you're building a model team, we tend to think we are using all these AI algorithms and all. End of the day, it's actually impacting real people there. So keep that in mind. Anytime we are building the model, it's not about the accuracy. It's more about like, building a more fair model here, not a biased model here, right? Here is one more thing, team. I was just trying to pull the data here. Whenever we are actually looking at the applications, we tend to see there is language models tend to have like a 40% preference for upper caste names here, right? That's always a problem. So we tend to have this religion, ethnicity, caste, creed, and everything. You try to do that. The language model tries to have some kind of a 40% preference over here. Again, why did it happen? The training data. The training data was not particular, right? Same thing with the translation systems here, team. Translation systems, if you want to come back and say, when you are actually, try that with ChatGPT, try to ask, put a prompt there, you will definitely see there could be a gender bias. You might see a gender bias, how it actually responds whenever you're trying to do some Hindi to English translation systems, right? And rural applicants, this is the other thing I was trying to say, team. Rural applicants versus urban applicants, when they go to a bank and you are trying to apply for a loan, the credit scoring algorithms will always tend to show some kind of a bias over there, right? Speech recognition is the other thing. We all have accent, right? Everybody has some regional accent here. So what happens? Like if you have an AI system which is actually listening to us, which is actually recording our accent, and the minute it gets to see like, okay, I know this accent and I have my own bias against that particular accent, you get to see that, the regional accent recognition shows the disparities of almost up to 30%. More than quarter, more than 25%, you get to see some kind of bias creeping in there, right? So how do we actually detect the hidden bias here? Think about it, right? Look at the different data sources we have, team. You come back and say, it's consistently decline, it's consistently accepting a credit application from urban people. Go back and then say like, okay, yeah, is there anything that's suggesting my model that this person is coming from a rural background? So is there any way I can actually take out that signature over there? Always an important thing for you to understand, like, which feature is important for you when you're building a model. Use the sharp technique, use the lime technique over there, right? There is also a Microsoft Fairlearn module team. This actually used Fairlearn. I think it's available in Python as well. Even in Python, you have a Fairlearn package that actually can see if our model is biased more towards certain demographics. Is your model coming back and saying somebody will repay the loan if the gender is female? The minute it says gender as male, it's trying to reject it. We have a problem over there, right? So if you have the detection noticed, then this unsupervised detection will not be an issue for you. So if you go back and then say if there are any performance disparities, the accuracy is good when you're predicting rural people, but the accuracy goes down when you're predicting urban people. You can actually go back and then see like, I see that bias there. So here are some techniques for you. How do I know the model I built has got bias or no bias? You can use these techniques here, right? And then tools again, to team quickly, right? Google has got this what if tool. So you build a model, you can definitely use this. Most of these are fair, most of these are free. I think this tool is, it comes with subscription package. There is a Fiddler AI that will detect the fairness of our models. There is also IBM AI Fairness. There is also a Fairlearn model, Fairlearn package in Python that's free. Pass through this one. Anytime you build a model here, team, it's important for you to actually use any of these tools to find out, is my model biased? Is my model fair or not here, right? So always think about it. Apply all the equality constraints during the model training. Ensure that the training data is all good. We're not putting in all the human bias there. Use the adversarial techniques. So in other words, like, let's say if you tend to think like people who earn more tend to spend more, there is a high correlation over there. So you don't want to consider both these factors and then build a model there. So that's what we are looking for. If we see that there is a high correlation between people who earn more and then spend more, and you are trying to predict like what will be the spend for the next 3 months, that might be a little tricky. So you can actually use this adversarial debiasing technique there, and then like, augment the data. You augment the data. So there are some techniques like SMOTE and other ways, wherein like, let's say you give like 1 million credit card transactions. 99% of them are fair transactions, 1% are illegal transactions there. So if you have such an unbalanced data set, it's important for you to augment the data here, right? And anytime you build a model, check with these fairness tools and then do the post-processing here, team. Ensure that, your model is not biased. It's trying to do the fair predictions over there. A couple of good slides for you. If you are using Fairlearn, maybe Bhavna, going back to your question about like how do you actually do it with the code, you can install this in Python. You can use pip install Fairlearn. You build a model with many of your favorite packages, scikit, pycaret, whatever package you have. You actually evaluate the model fairness across the demographic groups. And if you think there is a bias, go ahead and then tweak the algorithm, or maybe tweak the training data over there, right? Always a good idea to have an interactive dashboard, team. So what happens if I increase more of these males, more of these females? Is my accuracy still holds good, or is it going down, or is it going up? It's important for you to visualize the data here, right? Same thing if you are looking for some kind of a technical solutions here, team. If you're looking for some non-technical solutions here, always have team with varied backgrounds. Diversity always helps, right? Whenever you're working as a team, always have diverse development teams so that you'll have like a different ideas, and that will actually reduce the bias over there, right? Involve the stakeholders from the very early stage. Whenever you're ready to build a model, tell them saying like, okay, yeah, I'm trying to build a model for this healthcare system or a finance system or for the HR system, right? Involve the stakeholders, get their opinion. Sometimes we might be hearing something that we don't want to hear, but still stakeholders will tell us like, okay, which features to consider, which features not to consider. Regular bias audits here, team. This is something that's picking up big time. It's not that you take the data, you build a model, and then like you push it to the production, right? It's always an important thing for you to conduct regularly this bias audits. Is my model still holds good, right? Is it really doing good without having any kind of bias over there, right? It goes the same thing with the continuous monitoring, right? You go back and then say, if there is a bias that has creeped in into our model, maybe a good idea for us to tweak the data there, or maybe tweak the model there. So think of these main factors, team. My key takeaway from the whole thing here is fairness is extremely important. Make sure you are building the model. The accuracy is all good across all the population groups. Never ever forget the whole ethics part. Understand, like, it aligns with the human rights and the societal values there. We can't build a model that is unethical over there, right? Just because like humans have a tendency to show the bias, to show the judgment, to show the discrimination, reject an applicant, we can take those human errors and build another model here. Ethics need to be considered, and you have to have a broader social impact here, right? Accountability is important. You are making the AI responsible to make the decision. So if so, like, are we actually designating some individuals who are actually overseeing these algorithmic decisions? That's important as well, right? Transparency, the fourth factor, the fourth pillar is important as well, team, so that you can actually explain the decisions to the affected people. Why was your scholarship application got rejected? Why is that, like, we can't proceed with your loan application? Why is that, your candidates, you are not a good candidate for this particular job? It's important for us. We can use AI, but it's at the same time, our decisions need to be transparent here. Remember this part. Make sure you have this AI framework loaded in your installed in your minds whenever you are building an application or an AI model. It has to be fair. You're considering the ethics, and also make sure that you are accountable, your model is accountable, and you are able to explain those decisions here in that way. Good, good. Questions, team? Any questions on these topics? I made a note about, like, giving you an example with the code. I will definitely consider a data set. I do have a data set. It's just that it has some confidential elements about the people names and all. I have to clean up. That's the ethical part, right? If I'm dealing with some kind of a population data set, I can't actually show the names or there are the addresses or the phone numbers. Unfortunately, the data I'm working on right now has got all those things. I have to sign an NDA, non-disclosure agreement, to do the project. But yeah, I'll definitely be able to share something, where you can actually use these fair learn packages on like a sample data set. One thing I just wanted to share your team, you are more than welcome to reach out to me. This is my LinkedIn profile. I will definitely put that in the chat. Do let me know. I get excited when somebody asks something about AI. I will definitely try to share my insights there. Feel free to send requests if you are working on a project or something. If you need any kind of help, team, in terms of like providing some insights, or maybe you just wanted to have like a quick check. If you're doing a project and you need some kind of help in terms of validating it, or if you need some help in terms of providing some insights or feedback, please feel free to reach out to me. I'm available. Just mail away. I will also put my mail here, team. This, it's a Dallas Data Science Academy, Vamsi at dallasdatascienceacademy.com. Sure, yeah. You can pass the information to the students and faculty here, Bhavna. But yeah, let me know. So that's all I wanted to share with you all, team. So do let me know if you have other questions.
Yeah, request participants, if you're having any doubts, you can share with our resource person.
No worries. If you don't have any questions at this point of time, team, as you absorb the content, you're more than welcome to send me questions later to that email or at my LinkedIn profile. I'll be able to answer. But if you have any questions or if you need any kind of explanation or any kind of practical insight, let me know. I'll be able to answer that.
Um, yes, please, any questions, if any, like you can share with our resource person. Okay, sir, I think we can move to
Definitely, definitely.
Hello,
Yeah,
Flagaro, for taking such a time and really accepting our request and giving more insights regarding how to build the models and tools to be taken regarding the artificial intelligence and also data science systems. So really, it's a great insight to you, from your side, sir, to us. Definitely, it will be very useful and helpful for us to move forward in the research of AI. Thank you once again, sir. Thank you.
pleasure is all mine. Pleasure is all mine here, team. Thanks,
Thank
thanks again for having me. We'll be in
thank
touch.
you.
Good luck, everybody. Yeah,
Surely, sir.
take care.
Surely. Thank you.
Take care. Bye bye.
Thank you, sir. Thank you. So, request, so we'll be posting the feedback link in the chat box. So, you can fill the feedback form. So, we'll be in the afternoon again meeting at 2 o'clock. So, request all the participants to join faster in the afternoon session. Thank you, one and all.